In 2007, Maersk sails into problems because of exploding oil prices.
The prices had grown enormously.
The oil prices challenge Maersk's business because of the engine's high consumption. Especially when the vessels travel at maximum speed, the engines are thirsty.
Moving very fast in water is very, very expensive, both in fuel and but also in pollution of the environment.
For decades, speed and more speed has been the mantra in the shipping industry, but Maersk realizes that it can't go on.
Going faster and faster and faster is definitely not optimal.
So Maersk forms a working group. The task is simply to come up with an excellent idea.
An idea that could involve all our vessels and at the same time save on our bunker costs.
Okay.
Suddenly the idea crops up. The solution to the problem is simply to slow down. Instead of steaming with full power at 24 knots, the idea is to ease the hand on the throttle and steam at half speed, only 12 knots, and save a lot of oil and CO2 emission. But immediately the idea meets a lot of skepticism and resistance.
To go on slow steaming mode right away, then you possibly get in trouble and will harm the engine.
The problem is the design of the engines. They are built to operate at full speed, and going down to less than 60% of maximum load can potentially lead to damage.
One typical concern could be rapid wear down of cylinder liners. That's very costly if you have a cylinder condition problem.
And in the worst case, slow steaming could even be dangerous for the crew.
We have seen bearing damages where the connecting rods break and went through the engine side.
Maersk agrees that there is a risk.
This is the turbocharger, and in case of a breakdown, the worst case scenario would be an engine room fire.
But based on their own knowledge, Maersk is certain that many of the problems with slow steaming belong to the past.
We knew that this was actually, we were able to do this, so we had to find ways around this.
Ole Krogh Jacobsen decides to launch an experiment to prove that slow steaming is safe with modern engines. So in 2008, several Maersk vessels steamed out in the oceans at low speed. A full-scale experiment with valuable engines is initiated. On a trip from North America to Singapore, one of the vessels slows down to as low as 10% of maximum load. When the ship arrives in Singapore, engineers disconnect vital parts of the engine and examine them. They can't find any damage, and the results are carefully documented.
And we got these pictures back and analyzed them and could confirm that there was no reason for concern.
A stamp of approval from the engine designers decides the matter.
That in itself made us quite proud.
Of course, we were quite happy when we saw these, that we actually could document that this was an acceptable way of operating the engines.
During 2009, the slow steaming concept spreads around the world, and the advantages are enormous. On a round trip from Europe to Singapore, a ship like Emma Maersk saves 4,000 tons of bunker oil, and CO2 emissions are reduced by 30%.
The goods will of course have a longer transport time. What Maersk Line is doing in order to compensate for that is that they focus very much on reliability.
What started as an obvious idea, but turned out to be extremely difficult to put into practice, is now a proven concept that has changed the shipping industry.
Been interesting in this project has actually been to change people's belief by producing facts.
I think we all agree that it has been really exciting to be part of a project that has an impact like this globally and not only within our own company.